Howdy! We're going to do related rates today, and we're going to start with an initial calculation on volume that we'll need. So, you probably remember that the volume of a conical cylinder, so with radius r and sort of total height a, is the area of the base, pi r squared, times 1/3 of the height, which is a. So the total formula is pi a r squared over 3. What we need is the volume of a partially filled conical cylinder. So something that looks like this. Volume of that. All right, so to do this, we're going to take the volume of the whole thing and then subtract off the volume of the top. So we know the volume of the whole thing, it's just how is that related to the volume of the top. So let's set up some notation here. All right, so let's say we have this conical cylinder. The whole height will be a, the radius will be r, and then we have the height to which it's filled, which we'll call h for height. And we want to know again sort of the volume of this bottom piece. All right, so the volume of this will be the volume of the whole thing minus the volume of just the top part. Okay. All right, so this volume we know, this was pi a r squared over 3, and this is the one that we have to figure out. Okay. So really figuring out that volume just means we know that smaller cylinder's radius and its total height. So I'm going to draw a cross section here of this conical cylinder. We slice it from the top right down the middle. Then this whole height is a, this is r, and this was the height h. The things we needed to know was the bottom, which we don't know yet, and this part here, which we don't know yet either. However, one of them is very easy to read off. This d is easy because the whole height is a, and we just subtract off h. So in fact, this d is just going to be a minus h. So we know that exactly, but we still have to figure out what the c is. And the trick for figuring out c is to use similar triangles. So similar triangles will be the small triangle up here compared to the large one. And I will compare their sort of bottoms, their bases, to their the vertical side. So for the small triangle, the base is c, and the vertical side is a minus h. But for the big triangle, the base is just r, and the vertical side is a. So this will let us solve for c. c will be r over a times a minus h. All right, so since we know that, then we know everything about that small cylinder. Namely, its total height here was a minus h, and its radius here was r over a minus h. So the volume of that small piece was pi, the total height, a minus h, and then that radius part squared. So that would be r squared over a squared times a minus h squared. You square everything, all over 3. And so this will simplify to pi times r squared, a minus h squared, all over 3a squared. Okay, so now we know the total volume. The volume of that top piece. So the volume of this part, where the total height was a, we cut it off at height h, and the bottom was radius r, was volume of the whole thing, which was pi a r squared over 3, and then minus the volume of the top piece, which we just calculated, is pi r squared. Ooh, this should have been a cubed. Apologies. A minus h cubed all over 3a squared. So that's the volume we'll need in our next example. See you soon.